All right, for today's lesson, you're going to be reviewing how to solve linear equations and inequalities and quadratic equations and inequalities. These are review topics from Math 1 and Math 2, but I did want to just kind of briefly go over these and make sure that you did get a little refresher on those. And the next thing we'll do is to talk about absolute value. So when we're solving linear equations, you're going to be looking at those inverse operations. So remember, inverse means that opposite operation. And then you're just going to solve them. You're going to combine your like terms. And then once you combine your like terms, then you're going to do the process of getting that variable by itself. So when I look at this first equation, I've always recommended drawing the line down the equal sign just so you know what's your left side and your right side. And then we have a parentheses here. So this number in front, this 2, means we're going to distribute. So we're going to distribute the 2 to the 4x and the 2 to the 1. So that's going to give me 8x plus 2 equals 3x. Now, the key to this is we now need to look to see if we have any like terms. So when I look at like terms, I only look at what's on the left with the left and what's on the right with the right. I'm not moving anything over yet. So if the left side does not have any like terms and the right side does not have any like terms. So now that we've determined that, we can start doing inverse operations. So I need to get the x's together. So this 3x, I need to move over here with the 8x, and it's positive, so I'm going to subtract the 3x over. And that's going to give me 5x plus 2, and there's nothing left on the right, so we're just going to say it's equal to 0. All right, then at that point, we need to get the constant over to the right-hand side, so we're going to subtract that over because it's already positive. And we're going to have 5x equals negative 2. And then we need to split this coefficient from our variable x. And in order to do that, we know that this is being multiplied, so that's technically 5 times x. So we're going to do the inverse of multiplication, which is division. So x equals negative 2 over 5 for our solution there. Now, I am going to show you how to check this in Desmos, just because you will have a calculator the entire time on your EOC. If anything like this comes up, you want to be able to use those. So using the calculator is different for equations versus inequalities. Equations, we kind of have to manipulate a little bit. The testing version of Desmos does not allow you to put equations in like they are. So like if I were to type in 4x plus 1 equals 3x, you can see I get that little error message because there's only one variable. So how do we handle that? Well, we're going to split the two sides up with each other. So I'm going to make two equations, and I'm going to do the left side. So I'm going to say y equals, and the y equals is important because you need a two variable equation, 4x plus 1. So that's the left side. And then I'm going to create another equation. I'm going to say y equals 3x. And what that's going to do is it's going to create a intersection between those two sides. So the intersection between those two graphs is going to be where your solution is. The solution is what applies to both of them. So really what you're doing is you're creating a system of equations, which we'll get into a little bit more later. But if you look right at the x value, so that x value is always going to be your solution, which is negative 0.45. So if I do negative 2 divided by 5, I get that same answer. All right, so let me go over to the next one. So for this equation, we do not have any parentheses, so we don't need to distribute, but we do have some like terms here. So on the left side, I need to combine my like terms, and on my right side, I need to combine my like terms. So I can see that I have a 4x and a negative 1x. So if I combine those, that's technically 4 minus 1, which is 3x minus 11. And then on the right side, we have our constants, which are 2 and negative 20. So if I combine those, that's going to be 2 minus 20, which is negative 18. And what that does is it just makes it so you don't have to move so many pieces around. If you combine them, then you have less to move. All right, so now I'm going to work on moving my variables together and my constants together. So right here, I have a 2x. That 2x needs to go with the 3x. So I'm going to subtract that over. I'm going to inverse that. That's going to give me 1x, or just x, minus 11 equals negative 18. All right. Then I have my constant, negative 11. I need to move that over with the negative 18. So that's a negative, so we're going to add it. Do that inverse. And I'm left with x equals negative 7. And again, you can do that same process we did just a second ago to check that. You split your left and your right. So I have 4x minus 11 minus x, making sure it's y equals. And then I have 2 plus 2x minus 20. All right, so let me zoom out a little bit here. Find that intersection of the two graphs. I can see the x value is negative 7. All right, so again, equations should just be a good review for you guys, but it's important to know how to do those just in case something were to apply later on. So now inequalities. Inequalities with linear functions is very similar. The only difference with the linear inequalities is when you solve an inequality, when you get to the very end and you multiply or divide by a negative coefficient, you got to flip that inequality sign. And the reason that is I think about it like this. If I have a positive 2 and I multiply it by negative 1, it's going to turn into a negative 2. If I have a negative 2 and I multiply it by negative 1, it's going to turn into a positive 2. So every time I started with a positive or a negative and I multiplied it by a negative, it turns into that opposite sign, which has to happen with the inequality in order for the inequality to be correct. So whenever we mess with a negative with multiplication or division, we got to flip the sign. But the rules for an inequality for solving are the same as if you were using an equation. So again, I have parentheses at the front, so I'm going to go ahead and distribute that 4 to the negative x and the negative 1. So that's going to give me negative 4x plus 1, or excuse me, plus 4 is less than or equal to, because it's opening up to the right, so the left side is smaller, is negative 2x plus 3. And now we look for like terms. I don't see any like terms on the left. I don't see any like terms on the right that can be grouped. So now we're going to start inversing. So I need to move that negative 2x over. So I'm going to add 2x to the other side because we're going to inverse that. And that's going to become negative 2x plus 4 is less than 3. All right, now I need to move the constant 4 to the right. So that's positive. We're going to subtract that over. So I have negative 2x is less than negative 1. And this is really where I need to think. So right now, this coefficient in front of the x is negative. So I'm going to have to divide by negative 2. So since I'm going to divide by that negative 2, that's when my inequality sign needs to flip. So instead of it being less than, it's now going to become greater than. And then a negative 1 divided by a negative 2 becomes positive. Now, here's the great thing about Desmos and inequalities. Desmos will actually graph an inequality as you have it versus an equation that it will not. So if I type this in exactly like I see it, it's going to do some shading. So how do I figure this out? Well, if I look at that shading and I see what's happening, think about it like a number line. So if I think about a number line where my negative's on the left, my positive on the right, on the x-axis, I have positive 0.5. Well, all the shading is greater than that. So therefore, it is a greater than function, which is exactly what we got right there. All right, and then for the next one, so I have 3x plus 2 over 2 is less than or equal to negative 2x plus 1. So when we're looking at this, the first thing that I've got to recognize is this 2 in the denominator is preventing me from doing anything with the numerator. So I need to get rid of that denominator first. Well, it's being divided by 2, so I'm going to multiply by 2. Now here's the most important thing. Once that cancels, I have 3x plus 2 is less than or equal to. That 2 is being multiplied to the entire right side. That's one of the things that students forget more than anything. So that 2 is being multiplied to the entire right side, which means I'm going to need to distribute that over. So I have 3x plus 2 is less than or equal to, and then I have negative 4x plus 2. And then I'm going to start moving over my like terms, or my like terms from opposite sides. So this negative 4x needs to go over, so I'm going to add 4x. All right, so that's going to become 7x plus 2 is less than or equal to positive 2. This positive 2 needs to go over to the positive 2 on the other side, so I'm going to subtract that. And then I have 7x is less than or equal to 0. Okay, well, I'm going to divide by 7. That 7 is positive, so it will not change the inequality sign. And then x is less than or equal to 0. So anything that is less than or equal to 0 will make a true statement. So if I type that into Desmos, just to look at what I've got here, so I have 3x plus 2 over 2 is less than or equal to negative 2x plus 1. And I can see that there is a solid line there, which means it's equal to. I'm at 0, and everything is less than. So I'm going to pick a number that's less than 0. So I'm going to say negative 5. And right here, I'm going to plug in negative 5 where the x is, for every x that I see. All right, so what does that give me? Well, if I, hold on, actually, let me separate this. So for right there, the left side is negative 6.5, and then if I do the negative 5 for the right side, I get 11. Well, negative 6.5, so if I think about it right here, so negative 6.5 is less than or equal to positive 11. That is a true statement. Any number that falls in that range that I graphed just a second ago will work for that particular inequality. All right, I'm going to stop with linear, and you guys are going to work on part of the delta math for today. And I will start back with you guys on the quadratics and absolute value.